In our previous notebook, we saw the Lloyd-Max iteration that looked like the following. We would start our iteration with a random assignment of m reconstruction values, so code words y of k. Then we, using the reconstruction values, will compute the boundary values b of k as midpoints between two reconstruction values, so using the nearest neighbor rule. Then using the PDF of our signal and the boundary values, we would compute new reconstruction values y of k as centroids over the quantization areas. So it's the conditional expectation, centroid. And then we would go back to step 2 and update until we have sufficiently small changes that we define a value for epsilon. So this algorithm usually converges, so it finds an equilibrium and it doesn't change anymore, and it results in the minimal distortion d that was the expectation of the error, squared error that we saw. So it's interesting to notice that this can be generalized to a multi-dimensional case, what is called the vector quantization.